Assalamu alaikum. Dear learners, I hope you are fine and doing great. In today's video, I am going to show you a number of things. We are going to design an HMI that can be used to design the whole digital twin or the SCADA system for your facility. So in this video, if you don't have a hardware HMI, then we are going to see how you can use your laptop or computer to simulate an HMI and connect it with your real PLC. So the HMI will be running on our PC while we have a real PLC controlling our facility. So to do this, the very first thing is, of course, we are going to create a new project. Over here, you need to configure a device, then add new device. In the controllers section, you can go into your required controller. In the previous videos, I have already used this S7 1200 series PLC. But today, let me show you that how you can make your system detect the PLC automatically. So if you don't know the exact model of your PLC and you only know that you have this 1200 series PLC, then you can come over here, and over here you can see unspecified CPU 1200. You can open it up and select this PLC. That's it. Now you can click add. Later on, our system will automatically detect that what PLC is attached. So I have the PLC over here. I can double click on it to open the device view. So in the device view, the system is already giving you this warning that the device is not specified. So either you can use the hardware catalog and once again specify the CPU on your own, or you can click on this detect. So I have already connected my PLC with an Ethernet card of my laptop. So I should be able to detect it automatically. So over here in the type of the PGPC interface, I'm going to select Ethernet, and the PGPC interface will be my Ethernet card, which is this first one. So after selecting it, I'm going to click on this start search. It will take a bit. And over here, you can see that it has detected the device. So now I'm going to click on detect. And that's it. Now over here in this tree, you can see that the CPU is 1215C DC DC DC. So this is my PLC that has already been attached with this laptop, and the system has recognized it. So the next thing we want is we want an HMI over here. So once again, I'm going to go over here in add new device. I'm going to double click it. And from now the HMI panels, I can select any panel which I want because I'm going to simulate that panel on my laptop. I'm going to go with comfort panel 7-inch and this TP700 comfort. Make sure that you have checked this button so that the wizard starts. The wizard allows you to connect the PLC with the HMI quite easily. So in the first screen, you can drop this thing over here down and select the PLC. Then you can go into the next screens and choose some default options. So I've closed all the headers. I don't want anything to appear as header in my HMI. If you want the alarms, then you can keep these checked. Otherwise, you can uncheck them. If you want to add more screens, you can add those screens over here, but obviously you can add these things later on. So you can go through these things and click on finish if you are at the last step. Okay, so now I have added an HMI. You can see over here in the tree that I have an HMI and a PLC. So now I have two devices. So first I'm going to program a simple program in the PLC, and then we are going to design the HMI. So expand this PLC, and you can go into program blocks and the main. Over here I'm going to design the ladder diagram. But before starting the ladder diagram, it is a good practice to define the PLC tags. So I'm going into the PLC tag section, and in the default tag table, I'm going to define the tags. So the first tag can be the start button. I'm not going to use any real inputs. Instead, I'm going to use the memory bits so that I can control these memory bits through HMI. So I don't need I over here, so I've replaced it with M. Second tag can be of a stop button. Then the third one can be motor 1. And for this thing, I need it to be an output. So I'm going to change this M to Q. And over here, it is going to be 0. And now let's add another motor over here as motor 2. And I guess that's it for this program. So now I'm going to go back to my main block. So in the first rung, I'm going to add a start switch. Then it is going to be a normally closed stop switch. And when I press the start switch, the motor will start. So for as long as the start switch is pressed, the motor will keep on running. So I'm going to label this thing as start. The second switch will be the stop switch, and the last one would be motor 1. So once motor 1 is running for maybe 10 seconds, I can start the other motor as well. So for that, I need a timer first. Over here, the motor 1 switch will control the timer. I can get the timer over here from timer operations and then this T on timer. You can click and drag it over here to place the timer. I can name it as M1 timer. And for preset time, I can type in 10 seconds. And once this timer has done timing, I want another motor to turn on. So over here, I can use the other output, which is of motor 2. So once motor 2 is running, maybe I want motor 1 to stop. So I can place a normally closed switch over here and label it as motor 2. The next thing I want motor 2 to run for maybe 7 seconds only. So once again, I need a new rung. And then over here, I'm going to insert a switch for motor 2, and it is going to control another timer. I'm going to place another timer over here, name it as M2 timer, and set its preset time as maybe 7 seconds. So once this timer has done timing, I need the motors to start the sequence again. That is, motor 1 should start again, or if the start switch is off, then everything will obviously stop. So I can use the Q bit of this timer over here. It is M2 timer and it's Q bit. So I hope this program works fine, but if it'll have some errors, we can rectify it later on. So that's it for this ladder diagram. I can compile it by going over here and click on compile. Okay, so there are no errors or warnings, so we are good to go. Now I can close this PLC and come to this HMI. So over here I have expanded the HMI, and then on the screens I'm going to go into the root screen. Let me zoom out a bit so that we can see the whole HMI over here. I don't need this text, so I'm going to delete it. And now I want a starting push button and maybe an emergency switch. So those can be found over here in the libraries. And then in this section of buttons and switches, in these master copies, you can see that there are a number of things over here. So I'm going to go into this section of push buttons. The very first thing is a push button which is emergency, so I'm going to use that, and I'm going to click and drag it over here. So this is my emergency stop button, and then I can use a push button that will act as my start button. So I can place it over here. After that, I need to show something that will depict a motor. So I can come back to this toolbox, and over here in the graphics section under these controls, I can close these controls. I don't need anything over here. So under this graphics section, I can expand this WinCC graphics folder. And then in the equipment, there are a lot of things over here. In automation, I can, let's see if I can find motors over here. Yes, there are motors over here. And if I click on this animate block, I have some motors over here. So I can use these motors, or I can click on this motor and I have several motors over here as well. So I can use all these graphics to display my motor. So what I'm going to do is I'm going to use a green symbol to display a motor which has turned on, and a red symbol to display that the motor is still off. So I'm dragging this green and this red motor. Sorry, I will need this green one as well. Okay, so now I have these two things. These two graphics will be used to depict my motor 1, whereas I'm going to use another thing, maybe this motor as motor 2. So this will be the graphics for motor 2 when it is switched off, and this will be the graphics when motor 2 is switched on. Okay, that's it. Now the very first thing is I need to place my things correctly in order. So I want green motor to be over here, and I want red motor to be on top of the screen. So I'm going to right click on it and change its order and ask it to bring it to front. That's it. Okay, now you can do this, then you can hide the green one completely behind this red one. So because, and I'm going to do the same for the motor 2 as well. Once again, I'm going to bring it to the front, and I'm going to hide the green motor completely with this red one. That's it. Another thing I can do is I can go to this basic elements and add a text over here. I can type in motor 1. So this is my motor 1, and I can copy and paste it and place it somewhere over here, and I can write motor 2 over here. I guess this is enough for the HMI, and now we can see the things, and now we should get the things going. So before we can do anything, let me compile this HMI. So I have the HMI selected, and now I'm clicking on this compile. So whatever device is selected over here in the device in this tree, and if you click the compile button over here, that device will be compiled. So let me compile this HMI first. Okay, so that's it for all the things that we want on the HMI. Now I want to program these things. The very first thing is this start switch. So right click on it, select properties. Let me move it a bit up. Okay, so now come in the events tag, what we want to do when the switch is on or off. So when the switch is on, I want a tag to be 1. So I want to set a tag or a bit. So I'm going to select this set bit function, and over here in the tags field, I'm going to point it to the PLC tag of start. So over here in the PLC tags and the default tag table, I can see this start tag. So whenever this switch is on, this start tag will be set. And if this switch is off, so I'm selecting this off function over here, and I'm going to add a reset bit over here. So whenever this switch is off, I want this start tag to become 0. So I'm going to add start tag over here. Okay, so now if you want to show some animation, that if you are pressing a switch and you want to show the animation that the switch is being pressed, you have to come to this animation section, and in the tag connection, you can go to this tag property and the process value. So if you are using the animated switches or buttons, then you can see this option. Otherwise, if you are using some static elements, you can change their colors or you can do other things with them. So as this switch is an animated switch, I can connect it with the process value of the start tag. So I have selected the process value, and over here I can point it towards once again the start tag. So whenever the start tag is 1, it will have this green light on and the button can be seen as pressed, and otherwise it will be this 0 or red light on and the switch will not be pressed. So I'm going to do the same thing with this emergency stop, and I've selected it. In the properties, I'm going to go into the events once again, when this switch is on, that is, it has been pressed, I want to set the stop bit. So I've selected the set bit. Once again, I'm going to go into the PLC tags. Over here, the stop tag. Now for switch off, I'm selecting the switch off section, and in the function, I'm going to add a reset bit function. And of course, I'm going to point it towards the stop tag. And for the animations, once again, I'm going to go into the animation section. In the tag connection, I'm going to connect it to the tag property and the process value. The tag is for this thing is going to be the stop tag. That's it. So now hopefully our buttons will work, and let's come to these motors. So I've selected this red motor which is on top, and what I want to do is that when motor 1 is on, I want to display the green motor. So I want this red motor to disappear. I've selected it, and in the display section you can see over here I can change its visibility. So click on this new icon, connect it to the motor tag, which is this motor 1 tag in the PLC table, and over here you have to select single bit because we are just going to see one bit, which is motor 1. So if that single bit is set, I want it to be invisible. So whenever this motor 1 bit will be set, this thing will become invisible. So behind that red motor there is green motor, so it will appear. That's it, and I'm going to do the same thing for motor 2 as well. So in the motor 2, I'm going to once again over here in the visibility, I'm going to attach the PLC tag of motor 2. In the single bit, I'm going to once again use the invisible. So I hope now everything is fine and we have done everything. So now it's time to check whether the HMI has been programmed correctly or not. So before going to the real PLC, I'm going to compile this HMI. So I've selected this thing, and now if I press this compile, this device, which is the HMI, it will be compiled. Okay, so HMI has been compiled and you can see that there are no errors, so we are good to go. Now we are going to come back to this PLC, and we are going to come over here in the main file, and we want this thing to be downloaded into our PLC. But before that, I'm going to do one setting which is critical for connecting your HMI with your real PLCs. So for that, you have to come into the control panel of your PC, and over here in the search section, select search for set PGPC interface. So you can see it over here. Click on it, and currently you can see that this S7 online step 7 is connected to PLC sim. I have already used my TIA portal to connect to a simulated PLC, so that's why it is written over here. Maybe for your case nothing is written over here. So whatever is written over here, you have to make sure that S7 online is over here. You can select it from the drop down menu, and then on this side we want to connect it to our Ethernet card because that's where the real PLC is attached. So HMI will be simulated using this step 7 system, and it will be connected to our Ethernet, which will be positioned over here. So over here in this section, you can see all the things with which this S7 can attach. You have to search for your Ethernet card. For me, it is this one, Realtek PCI, and you can see three options. If you make this thing go over here, you can see that active is written with this third option. So I'm going to select this third one. It will give me a warning, so I'm going to click OK. And now you can see that this S7 online step 7 is connected to my Ethernet card. So with this Ethernet card, I have connected the PLC, and this S7 online is going to simulate my HMI. So this is a critical setting that you need to do. And later on, if you want to use a simulated PLC to connect with your simulated HMI, you can revert this setting back to PLC sim, which is this one. Okay, for now, I'm going to go with this OK. And once again, OK. Okay, now I can download this program into my PLC, and for that I have selected my PLC over here and I'm going to click on download to device. So the PGPC interface is for the PLC is already selected, but for HMI the subnet should be selected. So you can drop it down and we have connected the HMI with our Ethernet. So I'm going to click on it. Although I don't have a real HMI, but the simulated HMI is connected to this thing. So I've selected this IE. And after that, I'm going to start search. Okay, so the things are loaded and now I can load the program into the PLC by clicking on this load. I'm going to go with continue without synchronization. Then over here in no action, I'm going to stop all. These settings are just for the first time. The next time the program will be downloaded very quickly. And then I can go with this start module and finish. Let me expand this thing so that we can see the whole program over here. Okay, now I can, before I move on to the HMI, let me see whether my program is running fine or not. So I'm turning on the monitoring. The program has been downloaded into my PLC. So now my PC is connected to the PLC. So the online status of all the things is being shown over here. And over here, you can see that the PLC is in run mode. To check whether the things are running correctly or not, I can turn this internal bit to 1. And you can see motor 1 has turned on. So timer is running. Okay, so after 10 seconds, the motor 2 is turning on and it is turning off this switch over here, which resets motor 1, that resets timer, and once again the things starts. So there is some problem over here. I'm going to stop the monitoring. And the problem is over here. I need to delete this thing. And once the motor 1 has run for 10 seconds, I want motor 2 to turn on, but I don't want this motor 2 to reset motor 1 or this run. So I want motor 2 to turn on and keep on running on its own. So for that, I need to have a branch over here. This switch can be motor 2, and I'm going to connect it over here. So now if motor 2 is running, it will keep on running on its own, whether motor 1 has reset or not. But I want motor 1 to stop as well. So as long as motor 2 is running, I want motor 2 to stop. So for that, I need a normally closed switch of motor 2 over here. And to stop motor 2 using the emergency switch, I can place this emergency switch over here as well. And once the timing of motor 2 is complete, I want motor 2 to stop. So I can use the M2 timers qubit over here as well. That's it. I guess now the things are fine. So I'm going to save the project and download this new program once again. Now you'll see that it will be downloaded quite quickly. Okay, the program has been downloaded. Now I'm going to start the monitoring once again. Okay, so let me make the start switch off. Okay, so the start switch is off. Nothing is running. You can see that on the real hardware as well. Now I'm turning on this start switch and motor 1 is on. On the real hardware, you can see that motor 1 light has turned on, which is the first output. And after 10 seconds, motor 1 has switched off and motor 2 has turned on. And the timer is running over here. After 7 seconds, once again motor 1 is has turned on, and the timer is once again running, and the things are going quite good. Okay, so if I modify this start bit back to 0, then everything should stop, and that's what's happening. Okay, so the PLC program is running quite good, and now we want to come towards the HMI. So over here in the tree section, I'm going to select this HMI. And over here, I'm going to start its simulation because I don't have a real HMI attached, but I cannot go with this download to device because there is nothing over there where I want to download the HMI. So I'm going to start with the simulation. Okay, so here is my HMI. It is now running. You can see this HMI and the monitoring screen concurrently. So let me make it a bit smaller. Okay, so that's it. Okay, so now when should I press this start button, motor 1 should turn on. Okay, you can see that this start switch has turned on. Over here you can see the start switch has turned on. In the real hardware it has turned on, and on the HMI the motor has turned green. And you can see that after 10 seconds motor 2 has turned on, so it has turned green, and this thing will keep on going. You can see on the real hardware it is doing the same thing, on this monitoring window it is doing the same thing, and on the HMI it is doing the same thing. I can press this emergency stop and you can see that everything has stopped. Now the start button will not do any good unless this emergency stop button is depressed again. So you can see that I'm pressing the start button but nothing is happening. Over here in the monitoring window you can see that the start switch is on and now it is off. I'm turning it on and off but nothing is happening. So I'm going to click on this emergency stop once again, and now the start button is on, so the sequence has started once again. So dear learners, I hope now you can design the HMIs on your PCs. If you have a touchscreen PC, then that would be fantastic, and you can install that touchscreen PC on your plant floor or on your office or in your office, and you can design the HMI over there, control the whole facility and everything from the touch of your screen. And I hope that you have understood how you can connect the PLC with the PC and the HMI running on your PC. So that's it. If you have any questions or if you didn't understand anything, you can go back to this video again and watch it again. And still, if you have some queries, you can always reach me out through YouTube comments or my email address. So till the next time, thank you and take care.